Hello, welcome to this walkthrough video. Today we'll be doing Advanced Statistics Paper 1 from year 2024. Question 1. The Olympic Games are held every 4 years. The least squares regression line for the winning times in the men's 100-meter races for each Olympic Games held after 1900 was calculated. The calculated equation, where t is the winning time in seconds and n is the number of years after 1900 that the time was achieved, is t equals 10.878 minus 0.0106 of n. Interpret the value of 0.0106 in context. That means for every n, the winning time decreases by this value. But this question is for 2 marks, so we need to take into the consideration that the Olympic Games are held every 4 years. That means we need to times it by 4 to say how much it decreases per Olympic game. So per Olympic game, the value is 0.0424. So we got a mark for this interpretation and for this. No Olympic Games were held in 1940 because of the Second World War. Estimate what the winning time for the men's 100-meter race in 1940 would have been had it been run. Give your answer correct to 2 decimal places. So first let's find the difference. How many years pass after 1900? It was 40 years, so that's our n. So let's substitute our n to the formula. And the answer correct to 2 decimal places is 10.45. One mark question, you have a mark for this. Point C. Explain why the least squares regression line may be unsuitable for predicting future winning times in the Olympic Games men's 100-meter races. First of all, that would be extrapolation, so unreliable to predict future. And second, the least squares regression line is linear. But in fact, we cannot decrease indefinitely with the winning times due to human biological limits. 2 mark question, so you got one for extrapolation and the other one for stating it's linear. Question number 2. Leona is analyzing the total number of goals scored in football matches. She estimated the probability of a certain number of goals being scored by the 2 teams in a match and displayed them in a table. Leona's table is shown in figure 1. So we have the total goals from 0 to 6 and the probability of scoring them. A match where both teams score the same number of goals is called a draw. Using Leona's table, explain why the probability of a draw is at least 0.1. So we could say that a draw would be when they both scored 0 or both scored 1, so the total goals is 2. Both scored 2, so the total is 4, and both scored 3, so the total is 6. But from this table and from the question, we cannot say really what the split of these were. The only thing that we can be certain is when the draw is when nobody scores. So we can say that a game with 0 goals must be a draw. That definitely will be a draw. There is no other way. So that's why it's 0.1. and you have a mark for that. Moving on, find the highest possible probability of a match ending in a draw. So this bit we can actually differ, where they both scores 0 or 2, or both scored 1, meaning 2 in total, 4 in total, and then 6 in total. So the first probability was 0.1, the second 0.3, third is 0.1, and 0.05. Total probability of draw is 0.55. Here you have one mark for stating those and another mark for the total. Moving on, state one limitation of using Leonard's table given in figure 1. So we have a few possible answers to that. One of it is that the upper limit of 6 goals in total is not realistic, as we can always go further. Second of all, we cannot say was it a winning game or a draw. Also, we don't know how she estimated her probabilities. One is enough from this to get a point. Leonard models the number of matches with 3 or more goals scored in a tournament of 64 matches as a binomial distribution. State the parameters for Leonard's model. So obviously 64 would be the number of trials, n. And then we need to find the probability of 3 or more goals scored. So that's 3, 4, 5, or 6. And the probabilities were 0.25, 0.1, 0.05, and 0.05 again. And the total of those is 0.45. Number of trials is 64. So we got a mark for this probability and number of trials stated. Use distributional approximation to estimate the probability that in a football tournament with 64 matches, at least 30 matches have 3 or more goals scored. So let's start with the variable y. Approximation means that we will be using the normal distribution, and for that we need mean and variance. To get a mean, we are multiplying number of trials by the probability of success. So in that case, that's 28.8. And then the variance is just the mean times the probability of failure. So that's variance, and standard deviation is the square root. Approximately that will be 3.98. Squared. Now let's move to another variable, x, being the number of matches where 3 or more goals were scored. And we are looking for the probability that our x is more or equal than 30. So we will be doing the continuity correction with our new variable y being more than 29 and 5 and a half. In order to do that, we need a z-score. So that's our value less the mean divided by standard deviation. And that is approximately 0.176. And the probability of z being more or equal to 0.176 is approximately 0.431. For that 4 marks question, you will get a mark for the normal distribution, for the mean, for the correction, and for the final figure. Comment on the reliability of your approximation used in D. So we can say it is reliable as n is large enough and probability of success is close to a half. For 2 marks, you will get a mark for stating that it is reliable and both of the reasons why. State 2 reasons why Leonard's binomial distribution model may not be appropriate. So we can say that the teams will score different number of goals, so probability is unlikely to be the same in every game. Also, the probabilities are unlikely to be independent from one game to another, as players may got injured, for example. And you got 2 marks for both statements. Question number 3. Ned is a physics education researcher at a university. Ned wants to investigate whether there is any evidence of association between the number of sports activities that a student takes part in each week and their physics grade. Design an experiment for Ned to carry out. Your answer should include details regarding what data he should gather and how he can gather it, how Ned should choose his sample, which hypothesis test could be carried out with his data, and the hypothesis that should be used for this test. What data he should gather? So we can say that for each student, he needs the grade in a specific physics exam and the number of activities in categories. Then how can he gather it? He could obtain this data via the survey or the questionnaire. To choose the sample should be chosen at random and be reasonably large. The test would be Spearman's rank correlation coefficient test. Null hypothesis might be that there is no association between the number of activities in a week and physics grade for one student. And the alternative may be that activities and grades are not independent. For this 6 marks question, you will get 1 for the type, 1 for the way, 1 for random, sampling and how large it should be, 1 for Spearman, and 1 for hypothesis. At the end of the first year, physics students sit a multiple choice test with 70 questions. Each question has 4 possible answers. One student, Zamira, has not attended any lectures, so guesses every answer. Making any necessary assumptions, calculate the probability that Zamira scores more than 30% on the test. So firstly, let's find how many questions she needs to answer correctly. That's 30% out of 70 questions, which is 21. Our probability of success will be 0.25, which is 1/4, since we have 4 possible answers. And the number of trials will be 70. So we can introduce the variable x being binomially distributed with 70 trials and probability 0.25. We want to find the probability that our x will be more than 21. So that will be the probability of x being more or equal than 22. So now let's introduce another variable y being normally distributed. And what would be the mean? Mean is number of trials times the probability of success, which is 17.5 in our case, and variance, which is just the mean times the probability of failure. This is 13.125. And then standard deviation is a square root. Which is 3.62 to 3 significant figures. So now we can state the parameters. So now using the continuity correction, we can estimate this with probability of the random variable y being more than 21.5. Z-score, our x, take away the mean, divided by standard deviation, which is approximately 1.1. So the probability of z being more than 1.1 is approximately 0.136. For that 3 marks question, you will get 1 for 21 questions. For the binomial distribution and for the probability from z-score. For each assumption you made in B, give a reason why that assumption might not be valid. So we made a few assumptions to get the binomial distribution. One of them was that the questions are independent. This may not be necessarily true. Some questions may be related or even can contain hints for other questions in the paper. Another assumption we made was that the probability is fixed as 1/4, but this paper was multi-choice, so probability will vary from question to question. So we can say that the probability will not be constant, but also because maybe Zamira be able to rule out some incorrect answers, we don't know. For this 2 marks question, you will get one for independency and the other one for the probability being not constant. Question 4. Daria is running an experiment to investigate whether the consumption of an edible grain, quinoa, reduces blood glucose levels. Daria wants to be able to easily replicate her experiment. From a large group of student volunteers, Daria selected those aged 18 to 35 years with no health issues for her experiment. The table in Figure 2 shows the number of her selected volunteers in 6 groups by age and sex at birth. Daria randomly chose 10 volunteers from each of the 6 groups in the table. For each group, for lunch every day for 4 weeks, 5 were asked to eat 75 grams of quinoa, and 5 were asked to eat 75 grams of couscous. Couscous is another edible grain known to have little effect on blood glucose level. Volunteers had their blood glucose levels measured by a monitor. Measurements from the monitor were obtained at the start of the 4 weeks, then weekly throughout the 4 weeks. Each measurement was taken at 10 on Monday. State both the blocking factors Daria has used. So the blocking factors are age and sex at birth. Explain the purpose of taking the reading at the same time each week. Probably is to control for natural daily variation in blood glucose level, or to reduce the impact of other factors. Any of those. So in A you will get a mark for both, and in B you will get a mark for either. State 2 other measures that Daria has taken to ensure the experiment can be easily replicated. She ensured that volunteers are healthy and they all got the fixed amount of food for 75 grams. But that also can be that the fixed time to eat the grain at lunch and the test were taken at the same day and time every week. So you can choose 2, and for 2 from those you will get a mark. Daria finds that the mean blood glucose level for the volunteers eating the quinoa each day for 4 weeks reduces from 7.8 to 7.6. She concludes that consumption of quinoa reduces blood glucose levels. Comment on the validity of this conclusion, giving reasons for your answer. So there was no test to see whether the readings are significantly different. Therefore, the conclusion cannot be considered valid. In this 2-mark question, you will get 1 for pointing that there was no test carried out, and then the conclusion. State 2 improvements that Daria could make to her experiment. One could be a larger sample than just 10 people, and then the larger age range. And for both you will get a mark. Question 5. Aisha parks her bicycle at the train station on days when she catches the train to work. She is considering moving home to a new location and decides to find data on bicycle thefts at various train stations. The railway stations with the most bicycle thefts in England are shown in Figure 3. Show that the number of bicycles stolen from St Albans city station is approximately 86% higher than the number stolen from Maidenhead station. We would need the formula for the percentage increase. St Albans had 262 bicycles stolen and Maidenhead 141. So that will be our new and that will be our old. So the final figure is approximately 86%, which is exactly what we had to show. You will got 1 mark for the method and another mark for the final figure. Aisha claims that a bicycle parked at St Albans city station is 86% more likely to be stolen than a bicycle parked at Maidenhead station. Do you agree with Aisha's claim? Explain your answer. So, I do not agree with her claim, as the total number of thefts is indeed 86% higher, but the probability of a single bicycle being stolen may be different, and the data is not really sufficient to make a claim about the risk. In this 2-mark question, you will get 1 for whether you agree or not, and then for your reason. As well as data on the railway stations with the most bicycle thefts in England, the British Transport Police also has data on the number of secure bicycle lockers available at each station. Aisha calculates Pearson's product moment correlation coefficient, R, between the number of secure bicycle lockers at the station and the total number of bicycles stolen at the station between 2016 and 19 for all stations in England. Suggest a practical reason why the value for R might be negative. So a negative correlation. The more lockers, less number of bicycles stolen. So if a station has more secure bicycle lockers, then fewer bikes might be stolen. Why the value might be positive? For example, stations with many lockers may be as well the busiest ones, with many bicycles parked, which increases the chance of theft. Suggest 3 other pieces of data that should be considered in order to analyze how likely a bicycle is to be stolen from a given station. So that may be a number of bicycles parked at the station at a certain time in the week. Also the number of passengers at the station in average weekly, or the time when bicycles are reported stolen. For that 3 marks question, 1 for each. Question 6. Explain the difference between a discrete distribution and a continuous distribution. So first of all, a discrete distribution can only take centered values. and a continuous distribution can take any value within the center range. Erin owns several vans that she uses for her parcel delivery company. She allocates 8 hours for the delivery of all the parcels in a van. When a parcel is delivered, the van driver scans the barcode on the parcel. To check that the drivers are delivering parcels on time, one parcel in each van is chosen at random. When the chosen parcel is delivered, Erin receives a notification. Erin models the amount of time taken for a driver to deliver the randomly chosen parcel as a continuous uniform distribution from 0 to 8, as shown in Figure 4. Using Erin's model, find the probability that a driver scans the selected parcel within 2 hours of starting their deliveries. So we are looking for the probability of, let's say, our variable x being less or equal to, which is in uniform distribution. That's just the area in here, which is 2 times the probability density, which is 0.25. And that's 1 mark for that. A driver scans the selected parcel within 5 hours of starting the deliveries, given that they do not scan it during the first hours. Again, about the probability of our x being less or equal 5, given that it will be more than 2. From conditional probability, that's x being between 2 and 5, divided by the probability of x being more than 2. So the probability of x being between 2 and 5, that's 3 hours out of 8. And being more than 2, that's 6 out of 8, which is a half. 1 point for the method and another one for the answer. Find the probability that out of 20 drivers, at least 10 of them have delivered the parcel within 6 hours. So we have a binomial here with number of tries 20, and then the probability of within 6 hours. So that's 6 times the density, (0.75). And we are looking for the probability of x being at least 10, which is 0.996. For this 3 marks question, you will get a mark for the probability of success, for the distribution, and the final answer. Give a comment in support of Erin's model. So we can say that as parcel is randomly selected, it should be equally likely to be delivered at any time during the 8-hour shift. And for that comment you will get a mark. Then a comment against Erin's model. That maybe start of range at 0 is probably unrealistic, as there must be some time traveling from the pod. And for that comment you will get a mark. Question 8. Ingrid is taking part in a chess tournament. Each game she plays in a tournament is against a randomly selected player that she has not played before. In this tournament, there are 3 players that Ingrid classifies as stronger than herself, 7 players that she classifies as similar to herself, and 5 as weaker. Ingrid estimates her probability in this tournament that a game she plays ends in a win, draw, or loss, with the following probabilities shown in Figure 5. Find the probability that the first person Ingrid plays is a weaker player than her. So we will start from calculating how many players she can play against. That's 3 plus 7 plus 5. So together 15, and the probability of a player being a weaker one is 5 out of 15, which simplifies to 1/3. And for that you will get a mark. Find the probability that Ingrid loses her first game. So let's see each of the 3 potential scenarios. When she loses against the stronger one, so we need to select one person from 3 stronger players, and the probability of her losing is 45%, which is 0.45. Then for similar, we have 7 players out of 15, and probability of her losing is 0.25. And then the weaker player, which is 3 out of 15, and probability of her losing is 0.15. Added together gives us 77 out of 300. In this 3-mark question, you will get a mark to select a player, to pair with the right probability, and for the final answer. Find the probability that at her first 3 games are against 1 stronger, 1 similar, and 1 weaker player, and that she wins all 3. Candidates can play each other once only. So again, let's see 3 cases. For a stronger player, we have 3 out of 15 times the probability of her winning, 0.15. For similar, we have 7 out of now 14 people times probability of her winning. And weaker, 5 people out of now 13 times the probability of her winning, 0.45. Between them cases, we are multiplying as we want all of these to happen. And then at the end, we are multiplying by 6, which is 3 factorial, so we have 3 people permutated, giving us 6 possibilities. That gives us an answer of 0.00389. For this question, you will get a mark for the right probabilities, also for descending denominators, for permutations, and for the final result. Some chess tournaments do not randomly pair players, but follow a Swiss model where, after the first round, players play other players with similar results to themselves. If the tournament Ingrid is playing follows the Swiss model, how would this change the probabilities used in C? So we could say that players classified as stronger are more likely to win the first game. We can say that it decreases the probability Ingrid will be matched against players who are weaker, and so that the probability in C would decrease in the end. In this 3 marks question, you will get a mark for the 2 reasons and a conclusion.